Hello all, this is Shomajyoti Malik from Mahindra University. Today we will be presenting our work on near-field coupled toroidal metasurfaces based on Albright resonators framework. A plasmonic bright mode is a superradiant mode that can be directly coupled to the incident radiation, having a low Q factor, whereas a plasmonic dark mode is a subradiant mode with high Q factor. Such coupling between dark and bright modes, also known as mode hybridization in metasurfaces, have been widely explored. For example, in the case of electromagnetically induced transparency or Fano trap modes. Whereas the coupling scheme between bright or dark has been less explored. In our work, we have considered a metamaterial unit cell comprising of bright resonators, and we have shown that it is possible to obtain near field coupling in such structures. To begin with, we have considered a unit cell where we have taken one single split ring, and we have numerically simulated the transmission spectra for the same, keeping in mind that the electric field polarization is along the length of the split gap, and we have considered normal incidence in our case. The transmission response for the single split ring resonator shows a single dip at around 1 terahertz. When we consider three such split ring resonators in the unit cell, you observe that a frequency detuning occurs. Such frequency detuning is observed to be decreasing when we consider when we gradually increase the inter-resonator separation between the split rings. This is a direct consequence of the near field coupling between such bright resonators. Further, we also analyze the surface current response of our meta device, and we observe that in adjacent split ring, for the case of electric field parallel to the split gap, there is a formation of antiparallel magnetic moments in the adjacent split rings. These antiparallel magnetic moments in turn give rise to the formation of a toroidal mode. In our case, we observe a pair of such antiparallel toroidal modes appearing in our three-split resonator based structure. This is due to the near field coupling between the split ring resonators involved in our metasurface unit cell. So therefore we can conclude that it is possible to obtain near field coupling in a metasurface unit cell comprising of Albright resonators. In addition, it is also possible to obtain a toroidal excitation in such structures due to the bright coupling. Further, these toroidal modes are high Q factor modes that can be further tuned by tuning the geometry of the structure, and thus can be further studied for nonlinearity in such metasurfaces. Thank you.